Hello everybody, I hope everyone is having a great day so far. Today we are going to talk about how to multiply polynomials. And before we do that, let's just review the product rule. And we're going to do a basic example and one with coefficients. If we have two monomials that we are multiplying together, we add the coefficients, so the answer to this would be x to the 7th. And if we just put some coefficients in front of those monomials, let's say we have 2x squared times 3x to the 4th, well, we multiply the coefficients, so that would be -6. And because the x's have the same base, we add the exponents, that would be x to the 6th, because 2 plus 4 is 6. So that's a quick review of the product rule. Now, why did we review that? Because we are going to use the product rule repeatedly to multiply polynomials. So for our first example, we're going to be multiplying a monomial times a polynomial of any size. So for example, let's say we have 4x times a -5x squared minus 3x. Well, we're going to take the 4x and multiply it to each of the terms inside the parentheses. It's basically distributing with a little bit higher exponent. So we do 4 times -5, which is -20. We add the exponents. Remember, there's a 1 by that first x as the exponent. We get x to the 3rd. And now we multiply 4x to the second polynomial, or the second term of the polynomial, I should say, and we get -12x squared. After you multiply, make sure you look to combine like terms. But if I look at these two terms, they are not like because they do not have the same exponents. They do have the same variables, but they don't have the same exponents. So this would be my final answer. Okay, it seems like a step for today. It'll seem like an unnecessary step, but it is important. Anytime you go to multiply polynomials, you should look to combine like terms at the very end. Let's do another example. If we have -8x to the 3rd y, multiplying that to a -3x squared plus xy minus 4. Well, again, we're going to take -8x to the 3rd y, that term, and multiply it to each of the terms inside the parentheses. What I like to do for larger problems, I like to circle each term. Now, that might seem like a silly step for some of you that you might not like doing that step, but what it does, it really helps you mentally get the signs right. I'm really associating now the negative with 3x squared. I'm really associating the xy as being positive. I'll write a 1 here, just so I know that's the coefficient. Multiply the first one, we get 24x to the 5th y. I add the exponents for x, and I just rewrite the y because there's no y terms in the other -3x squared. Multiplying the second one, we get a -8 x to the 4th y squared. For the bases that are the same, we add the exponents. And finally, for the last one, we get a +32 x to the 3rd y. If I'm multiplying a number right here to something that's a term with variables, I simply will keep those variables with my answer and multiply the coefficient to the number. And again, after we multiply, we look to combine like terms. Since there are no like terms, this is my final answer. Okay, but again, make sure you look to combine like terms anytime you multiply polynomials together. So this is a monomial times a polynomial. So here's a problem I'd like you to try on your own in your notes. So go ahead and copy the problem down and then pause the video and answer it, and then check to see if you got the answer right. Okay, so hopefully you paused the video and tried that on your own. So we're going to go over the answer. Again, we're multiplying the -7y to the 4th to each of these terms. But if I look, I don't have any other y's in the second polynomial. So really, I'm just multiplying the numbers and putting the variables together. So the first one will be -21 x to the 3rd y to the 4th. For the second one, 12 times 7, that will be 84. So positive 84 x squared y to the fourth. And usually we write x first and y second, but the order necessarily wouldn't matter that much if we want to be, algebraically correct. For the last one, it would be positive 42 x y to the fourth. So for this particular example problem, because I was multiplying negative 7y to the fourth to 3 terms that didn't have any other y's in them, I really just keep the same exponents and variables and really just multiply the coefficients. Okay, so now we're going to multiply binomials. If you remember the previous lesson, a binomial is a polynomial of 2 terms. So we're going to take a polynomial of 2 terms, such as x minus 4, and multiply it to another binomial, with 2 terms, such as x plus 6. Okay. Now, there is a process that's an older process called FOIL that you probably heard of before, but we're not actually going to use FOIL because the way we're going to multiply is FOIL, and the way we're going to multiply anything larger than a monomial times a polynomial will work for every single type of multiplication problem we would use for polynomials. So what we're going to do is we're going to take the first x and multiply it to every term of the second polynomial. So let me start by doing that. X times x will be x squared. X times a positive 6 will be a positive 6x. So again, I took x and I multiplied it to each of the terms in the second polynomial. Now once I do that, now I will take negative 4 and do the same thing. Now I'll take the second term of the first polynomial and multiply it to each of the terms of the second polynomial. So we have negative 4 times x, which is negative 4x. And then we have negative 4 times a positive 6. That will be negative 24. So I'll let that sink in for a second. Again, we took each polynomial of the first, or each term of the first polynomial, I should say, and multiplied it to each term of the second polynomial. Now, once you multiply polynomials, you should look to combine like terms. In this particular case, we do have 2 terms that are like, and we combine them, we get a positive 2x. So I'll bring down my other 2 remaining terms, and this will be my final answer. So x squared plus 2x minus 24. Let's do another example together of multiplying 2 binomials. Here we have 2 binomials with a little bit higher exponents and more variables. 4x minus 9, the quantity 4x minus 9, times the quantity negative 3x squared plus 7x. The process that we used before is no different. So first I'm going to take 4x, the first term of the first polynomial, and multiply it to each term of the second polynomial. So 4x times a negative 3x squared will be negative 12x to the third. Remember, I add the exponents. Then I take 4x and multiply it to a positive 7x, and I'll get positive 28x squared. So now that I multiplied 4x to all the terms of the second polynomial, now I will take a negative 9 and multiply it to every single term of the second polynomial. So negative 9 times a negative 3x squared is a positive 27x squared. And negative 9 times a positive 7x is going to be negative 63x. Now remember, after you multiply, look to combine like terms. And in this particular problem, we do have 2 like terms we can combine. We have 2 terms that are x squared. So I'll rewrite the negative 12x to the third because we're not going to combine that with anything. When I add 28 and 27, we are going to get 55. So positive 55x squared. And then I bring down the negative 63x for my final answer. Okay, here is 2 problems multiplying 2 binomials together. So after you write these down, pause the video, try these in your notes, and then in a couple seconds we will go over them, or I will go over them with you. Okay, so hopefully you had a chance to try those. For the first problem, we're going to take the positive x and multiply it to each of the terms of the second polynomial. So we have x squared minus 6x. Now we'll take the negative 7 and multiply it to each of the terms of the second polynomial. Negative 7x, and then a positive 42. Now remember, after you multiply, look to combine like terms. We do have 2x's to the first power. So my final answer, I'll write above here, will be x squared minus 13x plus 42. Remember, when you combine like terms for your last step, keep the variable and exponent the same. And for the second problem, again, we're going to do it the same way. So I'll take 5x, and let me use a different color here. We'll multiply it to each one of the terms over here in the second polynomial. 5x times 11x to negative 11x to the third will be negative 55x to the fourth. 5x times a negative 3 will be negative 15x. Now we'll take the negative 4 and multiply it to each of the terms of the second polynomial. So negative 4 times negative 11x to the third will be positive 44x to the third. And then a negative 4 times a negative 3 will be positive 12. After we multiply, we'll look to combine like terms, but it does not look like we have any like terms for this problem. The only thing I'd probably like to do for my final answer, and to be honest, if you left it like this on a test where you wrote out the answer, it wouldn't be wrong, but on a standardized test, they would write it in standard form. So for the final answer, it should be negative 55x to the fourth plus 44x to the third minus 15x plus 12. We will actually do multiplying a binomial times a trinomial or vice versa another day, because I think this was enough for one day. So hopefully you answered all the questions throughout the video and took good notes. And if you have any questions, please bring them to class with you. We got to end with a picture, right? So let's see if we could find a good picture for us. And a couple of people told me that they saw some pictures from the gallery, so maybe you will actually see future pictures, but we got to end with a good picture. I love it. Maybe Mr. Pippage in the form of a dog there. It's got a nice tie there. I love that pic. So, all right, everybody, have a great day or night. And again, come to class with any questions, and I will see you next time.